Are we shooting? Are we filming? Is that what's going on?
You're going to just sit here and wait.
I was staring at the camera, and Kayla started smiling. I was like, yeah, we must be rolling right now.
Why?
Welcome back. Sorry. I was going down a wormhole.
Yeah.
You know.
Yeah, that happens. It happens in there.
I'm still waiting for the new one. Like, the 2023's out, but, like, the supply houses don't have it. So, still waiting for the new one.
Yeah. If I find, I'll grab a couple. If I find one,
Gavin's on the mission, too. Oh, okay. So, yeah.
Yeah. Why GFCIs?
Feel like there's the light. Feel like the lighting's different. Somebody move this chair.
It does feel different in here. I don't know what it is, but
why GFIs? Why GFCI?
Mm-hmm.
What does GFCI stand for?
You want me to tell you? Me to tell them?
Do you know?
Ground fault, circuit interrupter.
Mm-hmm. You looked for a second there. I thought, like, maybe you're like...
I got a good poker face.
What is the C?
What is the C?
What is the C? I mean, a lot of people say GFI. They don't even say the C.
Yeah.
Right? Because it's just a ground fault interrupter. But, like, because what else are you going to interrupt but the circuit? Right? Or is it a device? Is there a device that's a GFI? But there's still a GFCI.
Yeah.
GFCI.
GFI.
What is a GFCI outlet? Ground fault circuit interrupter. Piece of cake.
Yep. Boom.
This is what it looks like.
I don't know where we're going, so yeah.
I like the different plates, different trims. You know, it's GFI protection. GFI, go ahead.
I'm surprised that they're both straight, like they're both vertical. I'm surprised about it.
Because you were worried that...
I was just waiting.
Whoa, horizontal, man.
I looked at this one, and it must be one of those snap-on cover plates, right? It was super nice. I prefer this style because who wants to see screws, vertical or not? So
you prefer that style because you go behind the scenes and do your horizontal and cover it up and go...
Oh, right? Shit.
That's funny. You know, there's a lot of different articles in the National Electric Code that talk about ground fault circuit interrupting, like the reason for ground fault, the need for ground fault. It's so important because what happens is if something goes to ground, we want it to be able to turn the circuit off, right? Like we don't want it to just start to spark and arc. I mean, you think about
or feed power through whatever it is.
Or feed power into the grounding conductor, or because that grounding conductor also touches the grounded conductor. And for those of you that don't know, the grounding conductor is your green wire, and your grounded conductor is your neutral. So you start to get power on any of that system, then essentially you could have power to anything metal in a building.
Yeah.
Or residence.
Yeah.
So we want to make sure
if it doesn't trip the breaker, or it doesn't
right,
trip
so
the way
that's why
it's
you
supposed
have
to.
that protection, So, and we've seen that happen where power gets onto those systems. So if you get into the shower and you're like getting shocked by the handle, and or you're getting shocks at certain building steel. We've seen it happen where it wasn't protected, and it does cause damage, right? So
it's dangerous.
Right.
Just
so
dangerous, yeah.
You could have an entire building not grounded in metal and have electricity on it. And until that thing goes, finds a path somewhere to create an arc, right? Because that's essentially what you're doing is welding. You're bringing those 2 points together, right? Without any protection, it's not going to help. You're at risk, right? So...
Yep.
Common places we see GFIs, you talk about most of your GFIs covered in Article 210.8, which is like dwelling receptacles, really receptacles. And you find most of those commercial settings, commercial, residential. But I would say there's more topic on or there's more articles on the topic of receptacles than there is anything other thing. One of the questions on our service test is, at what point is an SES service entrance section required to be ground fault? Because your house has an SES, it's a service entrance section. We don't really call it an SES because it's just all-in-one panel, or a panel in a load center, or a panel in a meter socket.
Right, just smaller.
At what point does a commercial or a larger service need to be ground fault? It's 1,000 amps, right? A lot of people don't know where those things, and that's why it's one of our questions, right? We tried to figure out experience in the field, right? So we know that a residential guy coming in won't know that answer.
Right.
He's never seen anything more than 400 amps, more than likely.
Yeah.
I mean, I've seen some bigger, I've seen some services on houses that were pretty big size, but typically it's that 1,000 amp is the section. Like once you hit that 1,000 amp mark, you need to have GFI protection on the service itself. So those are some things that some questions that we asked to differentiate, to figure out those guys that are coming in. But on a GFI, like what are the most common places you see a GFI?
Around water, outside, bathrooms, garage.
Right.
Yep.
Kitchen.
Yep.
Hot tub.
Yep.
Pools. Right. Anytime there's a source for water, now water isn't really conductive. It's the minerals inside the water that are conductive. So, but Arizona's got hard water, right? So there's tons of minerals.
Water.
So that's a good conductor, right? So we want to think about. Let's look at the next question. Let's
when
go.
do we use that?
Let's just go right into the next question. Thanks, Kayla. So why/when do we use them, right? So we use them around water to protect something from splashing. Typically, water can get into those outlet holes, and and then anytime water touches the face, that means you're taking your hot, your neutral, and your ground and kind of pushing them all together, like in a wire net per se.
You could, yep.
Right, making them all conductive, like bringing those lines together. That's the word I'm looking for.
So like above counter near the sink and inside your kitchen is where you're going to need one.
Yeah.
Any outdoor receptacle need to be ground fault protected.
Because of rain or hose or weather. Yep.
Bathroom. And you can wire them in series. So you can have an outlet that's protected by ground fault, but not necessarily look like this.
Maybe a couple tabs.
So if you feed power into this outlet and feed outlets out from this device, those are going to be ground fault protected as well. By this outlet. That's why if you test some of these in your home, not just this will go dead, but multiple outlets outside or in your garage or something like that could potentially be feeding the load side of one of these receptacles.
So typically 6 feet from a water source. So like with anything within 6 feet, you have to have a GFI receptacle. But also the code says specific areas. So anything in the kitchen, appliances where you're plugging in because you could essentially plug in a blender that has that exposure, right? Like so.
Right.
Crock pots, boiling, whatever it is. Like so, check your codes. Make sure you're putting it in the right spot. If you have a specific question, comment below, and we'll tell you. We'll tell you what the answer is.
Yep.
But like in a kitchen, I guess you could have got some more wiring kind of diagrams. But in a kitchen, typically you feed the kitchen with a 20 amp circuit. And let's say I got a kitchen, and I'm feeding it with a 20 amp circuit, and it's got 8 receptacles. Do I need 8 GFI receptacles, Marcus?
No.
Why not?
Because you can feed all the other receptacles from one GFCI receptacle and protect all those outlets that are inside the kitchen.
Do we have a GFI in the warehouse? Hope so. I found an empty box. I was like, son of a bitch. Son of a bitch. All right, I found one back there. I didn't even look at the breaker, so this where I got to come like this? Can you see it?
Oh.
This one has a green dot on it, Marcus. What does that mean?
Hospital grade.
Oh, just checking. A lot of guys don't know that. So the thing about GFI, right? You have your line and your load. So the difference between a receptacle, a normal receptacle, is that both of the screws on either side are connected. They're connected by a tab in the middle that you can break that tab off, and then you can do, one circuit on the top for the top receptacle and one circuit for the bottom.
That's how they do the receptacle underneath your cabinets for your garbage disposal and your dishwasher.
Right, or a half hot in the bedroom for a lamp. So they like run hot to one, so it's constant, and then a switch to the other. So exactly right. You don't need a GFI receptacle under the sink for the dishwasher. It's not a wet location. Under the sink isn't a wet location.
Shouldn't be getting wet.
It shouldn't be getting wet, right? Like, just because there's pipes down there doesn't mean it's a wet location. There's pipes throughout the whole house. That doesn't mean it's a wet location. And I'm going to turn this receptacle upside down so it looks like normal people like it. This is how Arizona people like it. They like it to have a face. But manufacturer says this is the right way so that the ground is on the top, so that any water's falling down on it hits the ground first before it goes to the hot. So you have your line and your load. What you want to do, like Marcus was saying, you bring your line, your power coming in from the panel to the line side of this, and then anything that you want this outlet to protect, so this outlet is protected by this GFI. Any other outlet can be protected by this GFI too by feeding it from the load side. So we take the load side out to other receptacles in the kitchen. So there's one point of failure in the kitchen. So if the power goes out, you come back to this particular device. You can put GFIs in all of them.
You could. Yep.
If that's easy, right? Yep. You can do that depending on cost. Let's say you bought an old house and it wasn't, might be easier depending on how they wired it to just put devices in versus cutting the holes and getting the wire in.
Right.
GFIs are also allowed in the city of Phoenix if you don't have a ground wire in the house.
Yeah,
You can just you change the 2-wire device out and put this in, and that is current code for Phoenix to allow you to be current standard, right? To have that grounding device.
Ground.
So this is creating its own ground in that situation. Let's see. Let's see. All right. What do you do if they trip? So I'll tell you like this one is tripped, but it won't reset. Why won't it reset? Because it doesn't have power.
Yep.
So there's no power on this. So if you have, really, all you got to do is just press the reset button, and that should reset the trip.
It'll stick in there.
Yep. And then you can hit the test, and it'll pop it out to show you that it's functioning. But if you get to where, let's say, the outlets in the kitchen go bad, and you go over here and you press this button, could mean a couple things.
Yep. It could either mean that you have an active ground fault, or it could mean that this receptacle itself went bad.
Or there's no power. Right, there's no power.
Or there's no power to it.
So it could have tripped the breaker, right?
Yep.
Which ground fault went back to the breaker.
Yep.
And if you can't reset that, usually means there's no power. So you call an electrician, or you can go out and look at your panel and reset the breaker, and if it does it again, then you have a problem. Call an electrician.
Yep.
He'll come out. He'll open that outlet up. We'll take that outlet apart. We'll test it, see if there's power on it.
This one even has a light. Replace if red.
Yeah. A lot of them have lights now.
Yep.
I like that. That's funny. I like that light. Like if it goes out, turn the light on. If it trips, turn the light on.
Yeah.
But I don't really know if I like the green light just being on.
All the time.
All the time.
Just a little. Yeah.
Like I got one in my bathroom, and it's like.
Yeah, just like little green dots in the dark.
Yeah.
Yeah, I agree.
Just one.
It's not necessary.
Didn't used to be like that. They used to.
No.
They actually used to come on, but I think people don't realize they're working unless there's a light on. And green means good.
Green means go.
Green means always means good. Oh, here you go. So here's the reset button. And then the test button. And, you know, as you can see, some of them have different colors, but some of them are the same color as the device itself. So it'll say reset and test on the device. So you should be able to figure out how that works.
There's actually a device. There's actually a testing device you can get as well. You can plug it into receptacles around and press. It has a button on it to test.
To see if it's
to
GFI
see if
protected?
it's GFI protected.
And you can check functionality with those too, yeah. But these you want to make sure you go through at least every 6 months, make sure this is working. You know, activate the trip. That's it.
Thanks for watching.
I hope we answered your questions regarding GFIs. There's so much shit to talk about GFIs.
Yeah.
So if you
it's a
need
lot.
something specific, comment below and we'll fucking do a show on that. See ya.
Later.